Hello, ladies and gentlemen. We're going to do 8.2 today. We're going to be talking about integration by parts. Notice that your objectives say we're going to do new, fun, and exciting integration techniques. Sorry, bad grammar. All right, we did this last year, and it was super overwhelming. So I'm hoping this year that it will not be quite so overwhelming. A couple of things that you want to look for, see if I can find a highlighter, is it's particularly helpful for integrals that involve products of algebraic and transcendental functions. Okay? So for example, if I took this particular function and maybe I let u equal this part, if we're just doing plain old u substitution, then my du is 1 over x. That doesn't help me so much. Same situation on this one. If I let u be e to the x, the derivative is still e to the x. That's not helpful. And same thing on this one. Maybe I let u equal the sine of x, so the derivative is the cosine of x. Super not helpful. So integration by parts is another way of managing a technique just to help us get to the end result. So integration by parts. I don't know if you remember this, but it says the integral of u dv is equal to u times v minus the integral of v du. Sorry, so that would be one of the things that you're just going to have to memorize as we do our integration by parts. This is the part that we're hoping to be able to integrate by doing integration by parts. And so if you get to a point and you still have a mess, sometimes we have to do integration by parts multiple times. All right, so I'm going to give you some hints, things that make this process seem a little bit less overwhelming. So the first one would be let dv equal the most complicated portion of my original integral, okay? And then u is going to be everything else. And when you do these, just like we've talked about with other methods, I recommend that you write everything down and don't skip steps so that when you are substituting values in, if you make a stupid mistake, then you can still get credit for what you're doing. Another hint would be to let u equal the piece of the integral whose derivative, and I know it sounds like there's a hurricane going on behind me, but it's the heater because it's cold, whose derivative is a function that is simpler than u, and then dv is everything else. So I think the easiest way to do these is just to start doing some examples. And hopefully this year it will seem less overwhelming than last year. All right, so we're going to start with our first example. See if I can squeeze it in on the bottom of the page. All right, so I'm going to have the integral of x e to the x dx. All righty. So if I tried to do u substitution on this one, it's apparent because we kind of talked about it up top that it's not going to work. So I'm going to do my integration by parts. So I'm going to let u equal x, and my dv is going to equal e to the x dx. Well, if I look back at the original formula, so the integral of u dv is u times v minus the integral of v du, I need some other pieces to be able to substitute in. So if I go back to here and I take the derivative is just going to equal dx, right? Okay? And then if I start with dv and I need to get a v, then that means that I have to integrate, right? All right, so I'm going to integrate this. So if I have dv, I'm going to integrate, I'm going to integrate this to get back to where I need to be. So the integral of dv is v. It equals, the integral of e to the x is just e to the x plus c, okay? And I'm actually not going to add this plus c for right now. because when I integrate this, I'm going to generate a constant, and I don't need a ton of extra constants. So if I use integration by parts, then my integral of u dv is equal to u times v minus the integral of v du. And now I'm going to substitute everything in that I found. So my integral is going to equal u, which is x, times v, which is e to the x, minus the integral of v, which was e to the x, times my du, which is dx. Okay? So now it just seems really simple. So then if I finish my problem, then I have the integral of this is very easy, and I have e to the x plus c. And then this would be my integration by parts. So I would say the integral of x e to the x dx is going to be equal x e to the x minus e to the x plus c. Now, I could, if I wanted to, I could factor out the e to the x's, and I would get x minus 1 in parentheses plus c. But for right now, that is a great way to leave your problem. All right, first example wasn't so overwhelming. So let's do another one. Oh, look, my pen matches my shirt. That's pretty cool. All right, so the next example that we're going to do is the integral of x squared natural log of x dx. Okay, so again, regular u substitution isn't going to work because if I let u equal either piece, the derivative is not the other piece. Okay, so I'm going to do my integration by parts, which says that the integral of u dv is equal to u times v minus the integral of v du. So now I need to find all of my pieces. So in this one, then I'm going to set it up. So I'm going to let u equal, I think I'm going to let u equal the natural log of x, and then I'm going to write it right here, my dv is going to be the x squared dx, okay? Because remember, the other thing that I didn't tell you is your dv thing needs to include your dx thing. Boy, that's highly technical terminology. So now I'm going to find my other pieces. So I'm going to take du is 1 over x dx, and if I integrate this and this, right, I'm going to get v is equal to x to the third over 3. And remember, I'm not going to put my plus c because I'm going to get one from this step in the process. So now I substitute everything in. So I'm going to have u, which is the natural log of x, times v, and I'm going to write it like this, x cubed over 3 minus the integral of v, x cubed over 3, and my du is 1 over x dx. And then I'm going to clean this stuff up a little bit. I'm going to move this out front because I think it looks better. I think things just don't get confusing. All right? And then on this one, I'm going to take the 1/3 out front, and x goes into x cubed and leaves an x squared. So I just have the integral of x squared dx. Let me get rid of my grading screen. Oh, no! Where'd it go? There it is. Okay, whew, back in business. All right, so all I have left to do is integrate this guy. So I get x cubed over 3 natural log of x is equal to, minus a negative 1/2 x to the third over 3. Now I need to make sure that I get my c in. So I'm going to say the integral of x squared natural log of x dx is equal to, and I'm just going to clean up what I've done, x to the third over 3 natural log of x minus 1 over 6 x cubed plus c. And again, same thing as the previous example. I could factor out my x cubed things. I could factor out my third things, and then I could make it look a little bit more polite, but I'm good to go. Now here would be the thing that I want you to pay attention to. When you get to this point, if when I try to do this integration and it's not very polite, you can do integration by parts again. And I always think that's entertaining because I'm sitting over here doing hand motions and you can't see it. But if I get to this point in my math and this is still a pain to integrate, I can do my integration by parts Again, you just need to be very, very careful that you don't lose the math that you've already done. All right, so let's go ahead and do one more example, and then that's going to be it for today. So I'm going to have the integral of x squared sine of x dx. Okay? So as I start this one by parts, I'm going to let my u equal x squared, which means my dv is going to equal the sine of x dx. Okay? And remember that my integral of u dv is equal to u times v minus the integral of v du. Alrighty? So now I'm going to continue finding everything that I need. So my du is 2x dx. And then if I integrate this little guy and this little guy, I get that v is equal to a negative cosine of x. And again, remember, I'm not going to bring in my constant yet. So now I'm going to substitute all of my values into my integral, and I'm going to put it in this formula. So then this is going to be u, which is x squared, times v, which is a negative cosine of x, minus the integral of v, the negative cosine of x, put that little guy in parentheses, my du is 2x dx, okay? Now what I'm going to do is clean this up a little bit, okay? So this is a negative x squared cosine of x. This negative comes out, this 2 comes out, right? So I'm going to bring the 2 out and the 2 negatives out, so it's going to be plus 2 times the integral of the cosine of x. I'm going to put it in parentheses, x dx. So if you'll notice, this guy's not very polite. So I'm going to call, this is the result of my first iteration. I'm going to need to do it again on this piece, okay? So when I get to this piece, I'm going to do this in a different color so it's not too confusing. So I'm going to let my u equal x, then my du is dx, my dv is the cosine of x dx. I'm going to integrate both of those little pieces, and I'm going to get v is equal to the integral of cosine is the sine of x. Okay, this is the part that I don't want to lose. All right, so I'm going to rewrite this. So I'm going to rewrite a negative x squared cosine of x plus 2, and I'm going to put a big parentheses. Okay, so it's going to be u, which is x, times v, which is the sine of x, minus the integral of v, the sine of x dx, because my du is my dx. Alrighty. So now I can manage this, so I'm just going to go ahead and finish. And this is an x, by the way. Sorry, it looks like a v. So this is a negative x squared cosine of x plus 2x sine x minus 2. The integral of sine is a negative cosine plus 2 cosine of x, and then plus c. So if I were to report my answer, I would say that my integration by parts, and again, there's a couple of ways you could report your answers, is going to be equal to my negative x squared cosine of x plus my 2x sine of x plus 2 cosine of x plus c. The only other comment that I would make is if you're doing a multiple choice problem and this solution is not one of your options, what you might need to do is do a little bit of factoring to clean it up, and then hopefully that answer would be there. All right, my last recommendation when you're doing integration by parts is that you are neat and organized, because if you'll remember, we did a hairy problem last year that took like 3 or 4 different integration by parts. So because you chose not to do your classwork, shame, shame, but you want to make sure that you're not losing the pieces that you've already done, and you want to keep track of what's going on as you do your individual math. Alrighty, that's it for today. I will see you tomorrow.